Magnetic quantum number. It indicates the orientation of orbital in the electron cloud surrounding the nucleus. M must be integer from negative L, 0 to positive L. For example, when L is equal to 1, M must be negative 1, 0, positive 1. When L is equal to 2, M must be negative 2, negative 1, 0, positive 1, and positive 2. These are the examples of orientations of orbital. For L is equal to 0, 1, and 2. So, when L is equal to 0, M is equal to 0 because M is integer from negative L, 0, and positive L. In determining the value of M, we don't focus on the value itself, but more onto how many M values does it have. So for example here, when we have L is equal to 0, M is equal to 0, so we only have one value of M. One value of M shows one orientation of orbital only. Next, when L is equal to 1, M is equal to negative 1, 0, positive 1. So we have three values of M. Thus, we have three different orientations of orbital. So here we have px orbital, pz orbital, and py orbital. Three different orientations due to three values of M produced from this L value. Next, when L is equal to 2, M is equal to negative 2, negative 1, 0, positive 1, and positive 2. So we have 5 values of M. So we have 5 different orientations of d orbitals. S orbital has spherical shape with nucleus at the center. Only one orientation in S orbital because S orbital is when L is equal to 0 and M is equal to 0. So one value of M only, so one orientation only. This is an example for 1s, 2s, 3s. P orbitals have two lobes, one on either side of the nucleus. It has dumbbell shape. P orbital has specific orientation in space. P orbital is when L is equal to 1. So when L is equal to 1, M is equal to negative 1, 0, positive 1. Three values of M show three mutually perpendicular p orbitals, which means it has three different orientations. This is pz orbital, px orbital because it is on the x-axis. Finally, py orbital because it is on the y-axis. These are the example of p orbitals in three-dimensional shape. D orbitals when L is equal to 2, M is equal to negative 2, negative 1, 0, positive 1, and positive 2. D orbitals have 5 M values. So, it means D orbitals have 5 different orientation: dxy, dyz, dxz, dx square y square, and dz square. They are clover leaf shape. These are the example of 5 different orientations of d orbitals. The first one is dz square. It is called dz square because the orbital is on the z-axis. Next one is dxy. It is because the orbital is in between the x-axis and y-axis. Same goes for dxz. The orbital is in between the x-axis and z-axis. Similarly, dyz, the orbital is in between y-axis and z-axis. The final one is dx square y square. The orbital is on the x-axis and y-axis. This is a video of S, P, and D orbitals. The first one is S orbital, spherical shape. This is a combination of Px orbital on the x-axis, Py orbital on the y-axis, and Pz orbital on the z-axis. This is dxz orbital. Next one is dxy orbital. It's in between of x-axis and y-axis. Similarly, dzy axis or dyz axis in between, and this one is dx square y square, and the final one is dz square. It's on the z-axis. Each shell contains n subshell. This table shows the value of n, l, m, and the orbital notation, also the number of orbitals in subshell for each orbital notation. Let's have a look for the first one. N is equal to 1, L is equal to 0. Remember that L must be integer from 0 to n minus 1. So L is equal to 0 because your n is 1. So when L is 0, M is 0 because M must be integer from negative L, 0 to positive L. So the notation, look at the value of n, 1. So notation is 1. S from the value of L. So the value of L is 0. 0 means S orbital. So the orbital notation is 1s. Number of orbitals in subshell, only 1. Because it has one orientation only. Next, when n is equal to 2, L is equal to 0 and 1. So when L is equal to 0, M is equal to 0. Same goes for orbital notation as above. 2s is the value of n is 2. S is from the value of L, 0. So number of orbitals in subshell is 1. Next, when n is equal to 2, L is equal to 1. The value of M must be negative 1, 0, and positive 1. Orbital notation, look at the value of n, 2, and the value of L, 1. 1 indicates p orbital, so the orbital notation is 2p. Number of orbitals in subshell, m values or 3 values of m, so 3 number of orbitals in subshell. Next, for n is equal to 3, L is equal to 0, 1, and 2. 0 and 1, same goes for the one for L. And for L is equal to 2, you have the value of M, negative 2, negative 1, 0, positive 1, positive 2. Orbital notation, look at the number of N and L. So N, 3, L, 2. 2 indicates d orbital, so the orbital notation is 3d. And number of orbitals in subshell 5, because it has 5 different orientation, 5 values of m. Same goes to n is equal to 4 and so on. Example 1. What values of the angular momentum and magnetic quantum number, what values of L and M are allowed for principal quantum number n of 3, principal quantum number n equal to 4. So we are going to state the values of L and M for when n is equal to 3 and n is equal to 4. Remember that m must be integer from negative L, 0 to positive L. So when n is equal to 3, L must be 0, 1 and 2. And m values are according to the values of L. So when L is equal to 0, m is equal to 0, L is equal to 1, m is equal to negative 1, 0, positive 1. And when L is equal to 2, m is equal to negative 2, negative 1, 0, positive 1, and positive 2. For n is equal to 4, the L values are 0, 1, 2, and 3. The m values for when L is equal to 0 is m is equal to 0. L is equal to 1, m is equal to negative 1, 0, positive 1. When L is equal to 2, m is equal to negative 2, negative 1, 0, positive 1, positive 2. Finally, when L is equal to 3, m is equal to negative 3, negative 2, negative 1, 0, positive 1, positive 2, and positive 3. Example 2. For the following subshells, give the values of the quantum numbers n, l, m, and the number of orbitals in each subshell for 2p, 3s, and 4dxy. For 2p, the value of n is equal to 2. The value of L is equal to 1 because it is p orbital. So when L is equal to 1, m is equal to negative 1, 0, positive 1. So it has 3 orbitals because it has 3 values of m. For 3s, n is equal to 3, L is equal to 0 because it is s orbital, and m is equal to 0 from L is equal to 0. So you only have 1 value of m. So you are going to have 1 orbital only. For dxy, n is equal to 4, L is equal to 2 because it is d orbital. M is equal to negative 2 or negative 1 or 0 or positive 1 or positive 2. You cannot take all value of m because dxy is one orientation only. So only one value of m can represent one orientation because one orientation shows one orbital only. So you only need to write one value of m. It's either negative 2 or negative 1 or 0 or positive 1 or positive 2. Example 3. What is the difference between 2px and 2py orbital? So look at the 2px and 2py orbital. The difference between them is all the 3 orbitals are identical in size, shape, and energy. They differ only in their orientation with respect to each other because one is px, one is py. Px is on the x-axis, py is on the y-axis. They have different orientation.